Hi, so let me show you the input box here for this program, that is shear force and bending diagram drawer. So first I will go through these inputs, then I will show you those in the diagram also. Okay, so it is asking me total length of the beam. Okay, so total length can be a numerical value like 10, 20, 30 like this. So suppose 10 is the length. Then unit of the length can be meter, feet, like this, meter, feet, inch. Okay, so suppose meter is the unit. The unit of the load can be pounds, kilonewton, newton, uh, kilo pounds like this. So suppose kilonewton. The name of the node is the any name that you can give to the node. Suppose A, B, C, D like this. Then distance from origin is the its numerical distance from the leftmost end of the beam. So leftmost end, I will show you in the diagram. So let us suppose my A is at 0 from left end. So A is the starting point. Node carries, what does it carry? Does it carry load? Does it carry support? If there is a load, then you will choose L here. If there is support, you will choose S. If there is a if it's a free end, means there is no load, there is no support at this end, then that is capital E. So suppose there is a support, so I will write S here. Okay, and choose the type support, fixed, pin or roller. So there are three kinds of supports, and internal hinge is also included in the support. Okay, so internal hinge, I will show you what it is. Now what is fixed support? When there is a fixed kind of support, means a fixed support has three reactions: vertical reaction, horizontal reaction and couple reaction. So that is a fixed support. And pin support, or you can say hinge support, this one is a pin support. Okay, and roller is roller, it gives you only one vertical reaction, that is roller. So suppose I am having fixed support. Enter another load node detail. So because there will be some loads also, so yes, so suppose I am having a load at point B, which is at a distance of 10 meter from the left hand. So 10, and what does it carry? It carries a load, so I will choose L. And what kind of load? Load can be point load, it can be a uniformly distributed load, UDL, or it can be a uniformly varying load, means uh, load intensity changes from W1 to W2, means load is like this, it is not like this, I mean UDL, it's a uniformly varying load. So triangular load or trapezoidal load, that is uniformly varying load. And you have an option of moment also, you can apply a moment also. So for now I will choose a point load, that is concentrated load, that is single arrow vertical load. Okay, P. And what is the magnitude of the load? Enter the load value here. So load value can be suppose 10 kilonewton. So for now I will not choose any another node. So you have to enter no. Suppose you have finished entering all the nodes, then you will choose no, n. Okay, it can be a small n, it can be a capital N, it doesn't matter. Then enter, and it will give you the equations here, all the equations and values of the moment. These are the reactions A, Y, M, A, and your diagram will be plotted like this. Okay, so this is just the intro level. This is the shear force diagram, and this is bend diagram. Now these two diagrams it can draw. Okay, so that is the introduction. Now let me show you exactly what all these mean by showing some diagram. Okay, so this was the diagram which you shared with me, Stephen. Okay, so let me show you here. So you can see that A is a node because there is a load here. So when you, let me start again here for this problem, I will enter the values. Okay, so let me run this. Okay, so it is asking me what is the total length of the beam. So I have assumed some values here. Suppose this is 2 feet, this is 3 feet, and this is 1 feet. So this total length of the beam is 2 plus 3 plus 1 is, that is 6 feet. Okay, so I will write 6. Now unit of the length is feet, ft. So I will write here ft. Unit of the load, load is in kips, that is kilo pounds. Okay, this can be kilonewton, this can be kilopound, this can be pound, this can be newton. Okay, or whatever unit you are using. Okay, you simply write it like this. It doesn't matter, I can choose any unit, I can choose kg also. Okay, so it is uh, just for writing the values and unit at the end of those values. For example, in bending diagram you can see that axis shows the unit of the load, so this unit it will reflect in that diagram. So I will choose here kip because I have chosen kip here. Now let us start entering the nodes. Okay, so what are node? Node is this point A, suppose, because there is a load here, so this becomes a node. There is a load starting at C, this becomes a node. There is a load acting at this point, so I have given it some name. So you can assume any name. So I have given it a name E here. It was not given by you in your diagram, but I have assumed it. E. Then this is also a this is not a node. I mean, I will not include horizontal forces here. 3F is a horizontal load and 4F is also horizontal load, so I will ignore them because I am not drawing axial force diagram. I am not drawing normal force diagram. I am drawing only shear force and bending diagram, and I need only vertical loads and moments. Okay, so I will ignore these two. So D is not a node, but it is the ending point of this UDL, so I have to include it in here. I will show you how. Okay, and this is a support, so this becomes another node, and this is a what kind of node? It's a support node. And what kind of support it has? It has a fixed support. Okay, so it has a fixed support. So let me show you like this. So this is fixed support. Okay, and this is a uniformly distributed load which with intensity W equal to P, and I have assumed P equal to 10. Okay, so so W is equal to P and P is assumed to be 10. Okay, so this is a uniformly distributed load and it is denoted by U. Okay, for uniformly distributed load. And this is a concentrated load. You can say vertical, point, or concentrated. You can choose between point or concentrated. So it means same thing, that is concentrated load. Okay, and this one is also concentrated load Q. So I have assumed PA equal to 100. Okay, so this is the assumed values 100. Okay, so because this is a variable, I am not choosing variable, I am taking constant value 100. So vertical point load there denoted by P and its value is 100. Okay, and here the value of P is 300. Okay, I mean this capital P, not this P. Okay, so I will start entering the detail from the left hand. Okay, this left hand acts as the origin. So this is my beam A, B, and A it becomes origin because this is the leftmost point. Okay, so name of the node A. Distance from origin, A is the origin, so distance will be 0. Then node carries, what does it carry? It carries a load, so I will choose L here. Okay, what kind of load? It carries a point load because this is a point load. I have written here point or concentrated, so I will choose P. If it was a UDL, then I will choose U. Okay, if there is a couple like this, there is no couple here, but I will show you example of couple also. So okay, so I will choose L for load, and what kind of load? P. I will choose P. And what is its value? Enter the load value, positive if downward. So this is a downward, arrow is downward, so I will write positive 100. So for positive I don't need to write any sign, it's a positive. Okay, so this finishes my entry for this load. Okay, now I will move to C. At C there is a UDL. So first I have to choose, do you need to enter another node detail? Yes, I want to enter another node detail, and name of the node is C, and it is at a distance of 2 feet from the origin. So I will write X is equal to 2 here. And what does it carry? It carries a load. Okay, so I will choose L. Now it asks you what kind of load. It is a UDL, uniformly distributed load. When load is like this with intensity something, then it is a UDL. So I have to choose U. So I am writing U here. Small or capital doesn't matter. Now enter the load intensity W. So W is equal to P, and P I have assumed 10. So load intensity is 10. 10. Okay. So enter 10. Now enter the length or span of the UDL. So length span is 3 meter. This is the span of the UDL. So total length of the UDL is 3 meter. It starts from C and ends at D. So this is 3 meter. Okay. Now it is asking me, please input a name of the point where the UDL ends. So it ends at D. So name is D, where it ends. If there is no name given, you assume some name. Okay. Alright, enter another node. Yes, B is yet to be entered. So I will write yes, and name of the node is B, and its distance from the left end is 6. 2, 3, 5, 1, 6. Okay, 6. So X is 6. Now it carries a support. So I will choose this support S. So I will choose S here. Okay, so I entered S. Now it is asking me choose type of support: fixed support, pin support, roller support, or internal hinge. So this is a fixed support. Okay, this is a fixed support. So I will choose F here. F. So this is capital F, but you can choose small f also. It doesn't matter, or capital F. It's your choice. Now enter another node detail. No, I don't need to enter another detail. I have entered all the details. So I will choose now no N. Okay, so all my calculations will be reflected here, so you can check them here. And all these value MDMB equations for all these spans. So this is my reaction here, By, and this is my shear force equation for axis up to 2. From 2 to 4 this is my shear, and this is my moment, and 2 to 5 this is my moment, and this is my shear force equation. So all the equations and maximum values, they are included, and this is my shear force and bending moment diagram. Okay, so this is my shear force, and the shear force here is negative, 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 and bending moment is also negative, like this. So it is writing negative, negative, something like this. And these are the distances. This is 0, this is 2, this is 5, this is 6 meter. Okay, and this is the unit of the load, KIP, and this is the moment unit, KIP feet. So this, where does it come, this KIP came from? It came from here only. This is the value you had, we have put here KIP, that's why it shows here KIP. Okay, and length unit feet, it came from here. Okay, so this shows here also feet. So this is my shear force and bending moment diagram for your this problem. So I will go to desktop and save this. You can save this image like this. So if you click here, save, give it some name, and choose PNG, that is portable network graphics. Okay, PNG, or you can choose JPEG also. I think there is some option here. Yes, this is JPEG also. So you choose this, and it will get saved like a image. Okay, and save here. Yes. So this is your problem, and now I will take another problem for showing you the internal hinges also, and couples also, moment also. So now let us take this problem here. Okay, so this is my beam, and it is the compound beam in figure is fixed at A. This is a fixed support A. Okay, determine the reaction at ABC. ABC. Assume the connection at B is a pin. B is a pin, and C is a roller. So this is a roller. So there is a UDL here, and there is a couple here, couple or moment. Okay, it is a clockwise couple. So this direction is clockwise. Okay, if direction was like this, then it would be anti-clockwise, anti. Okay, but this is given this one is a clockwise couple, and this is a roller support. They have given me a roller. Okay, so this is a roller, and this is an internal hinge. Internal hinge is a point where moment becomes 0. Okay, and this is my UDL. Okay, so UDL is represented by U, and its intensity, load intensity is W, and W is given equal to 6. Okay, load unit is kilonewton, and length unit is meter. Okay. Okay, so let me enter these values now here. So CLS to clear the screen. Now let me run this program. Okay, so it is now total length of the beam. Total length is 6 plus 4.5, that is 10.5. So 10.5. Unit of the length is meter. Unit of the load is kilonewton. Name of the node. Now let us start from A. So name of the node is A, and its distance from the left is 0 because A is the leftmost end. Okay, and node carries a support, so I will choose S. And what kind of support is it? It is a fixed support, so I will choose F here. Now again I will choose node A. First I will write yes, I need another node. And what is the name of the node? A. I will, because this UDL starts from the same node, so I will again choose A, and its distance again 0. Now this time I will not choose L, I will choose I will not choose S, I will choose L for load. Okay, and what kind of load? It's a UDL, uniformly distributed load, so I will choose U. You can choose capital or small, doesn't matter. Now enter the load intensity W. So W is equal to 6 kilonewton per meter, so 6 kilonewton. Enter the length or span of the UDL. So it starts from here to here, and what is the length? It is 6 meter. So length or span of the UDL is 6. Don't write units, simply write numerical value here. You have written units here, it automatically understands that okay, this will be meter. Now please input a name of the point where the UDL ends. Where does it end? It ends at B. So I will write name of the endpoint B. Enter another node detail. Yes, because there is an internal hinge here, so this becomes another node. Name of the node B. X is 6 meter. B is at 6 meter from here. This is the origin. Okay, so leftmost end is the origin. So it is 6 meter. And what does it carry? It carries a support. So internal hinges, they come under support. So, and within support, choose the type support. This is internal hinge, so IH. And enter another node detail. Yes, I need to enter the couple moment at C. Yes, so I will write name of the node is C, and its distance from the origin is 6 plus 4.5, that 10.5. So C is at 10.5 from the leftmost end. So 10.5. And what does it carry? So first I will write this couple, so I will choose load. So couple is kind of load. Okay, what kind of load? This is a moment. So what kind of load? I will choose now moment, because this is a couple moment M. And does this node carry I will correct this one, and I will give you the code again. Okay, does this node carry a support also? Yes, there is a support at C. Okay, so it is checking that if this is a end point, so is there any other support or not? So because at C this is a couple, but there is a support also, so there is a reason why is it checking this. So but you simply give it a yes if there is a support. So yes, at C there is a support, I will choose yes. And enter the moment value. So moment value will be positive if clockwise. So this moment is positive, so I will choose 8 here. Okay, positive 8. If this was like this and anti-clockwise, then I will write negative 8 here. Okay, now enter another node detail. Yes, I have to write the support detail also, because I have done this, I have done this, I have done this, I have done this. Now I will uh, enter this. Okay, support. So name of the node again C. X is 10.5, and it carries a support S. What kind of support is this? This is a roller support, so R. Okay, enter another node detail. No, I have done I have entered all the details, so I will choose no. And then it will show you the solution. So this is my diagram, this is my moment and shear force diagram. And you can zoom. Suppose this value is not clear to you, so you choose this zoom button here and click on this part, it will zoom you. So this is basically 6 meters is showing the distance. And if you want to check the value, so this is my value 1.05 and this is the distance 5.41. So it is showing the maximum positive value of the moment at 5.41 meter. Okay, so this is my maximum moment and this is the maximum negative moment. Okay, so it will show you all the values. All right, so this is the distance, this is the value, and these units they came from here only because I had an kilonewton as a load unit and meter as distance unit. So these units also reflect in the diagram. Okay, and this is my maximum shear force, this is the shear force at respective distances. And if you want to save this image, click on this icon, this save. And how do you want to save it? You want to save like png, so png. Okay, so I have showed you all this just in the previous example. I hope you understand that. So I will close it now. And a few more things I want to show you. Suppose you are having a uniformly varying load. So I will clear the screen. So I will show you what is a uniformly varying load, UVL on beam. So this is a uniformly varying load, this kind of load. You can enter these loads also. Okay, suppose I want to solve this problem. So what is this kind of load? It is called uniformly varying load. Let me save this one. Desktop UVL. Okay, and save this one also. This one save. Okay, so UVL now I will write here. So this is a UVL. What does UVL stands for? It stands for uniformly varying load. UVL I have just skipped, so UV. Now it has two values. One is 200 Newton meter and 400 Newton meter. So this starting is denoted by W1. W1 is 200, and this end point end value it is denoted by W2 equal to 400. So you have to write these two values in my program for solving this one. Okay, so let us solve this one. So let me run it first. Okay, so total length is 3 plus 3, that is 6 meter. Unit length is meter. Unit load is Newton. This time it is N only, N, Newton. Name of the node, so A is my starting node. X is 0 because this leftmost end is my origin and it carries a support. So S, what kind of support? I can say this is a pin or roller because only pin and roller has vertical reaction and no moment. There is no couple reaction here. So this is a simple pin or roller. So you can choose either pin or roller. I will choose pin here. It doesn't matter. Now enter another node detail. Yes. So this point is a node because there is a vertical concentrated load here. Okay, so I will give it some name. Suppose I want to give it a name of D. Okay, and this is a concentrated load. Okay, also point load, we can say this is a point load. So concentrated or point load, whatever you want to call this, and P is equal to 100 here. Okay, all right. So let me enter this value here. Name of the node is D and it is at x is equal to 1 meter. So this is 1 meter, 1 here. And it carries a load L and this is a point load, so P. And enter the load value, it is 100 Newton. Positive if downward, means this arrow is to the down direction, so downward positive. If it was upward in this direction, then it would have been negative. I would write this minus 100 if this arrow was like this. If arrow was like this upward, then it would have been negative 100. Okay, but arrow is downward. So this downward arrow, it gives me positive value here. Now enter another node here. Yes. Now I will move to node C. This is the point where this UVL starts. So name of the node is C, and its distance from origin is 3 meters. So 3. Now it carries a load. What kind of load? Now you will choose UV. Okay, uniformly varying load, because there are two intensities of this load. So I will choose UV, UV, and enter. Now W1, enter positive down. So this is downward, so positive. And what is the value? 200. And W2 is the end point intensity. This is the 400. Okay, 400. Okay, and what is the span here? 3 meters. Please input a name of the point where UVL ends. So where does it end? It ends at B. It starts at C and ends at B. So I enter B. Now enter another node detail. Yes, because I have not written this. I have not entered detail about the support. So yes, the name of the node is B and X is 6 meter, and it carries a support. What kind of support? It's a roller. Okay, so this one is a pin. I will choose this one as a roller. R for roller. This is my roller R. Now enter another node detail. No, I have entered all the details. So N, no. And once you do that, it will show you the solution here. So these are the equations, and this is my diagram. Okay. So this is my diagram, and these are the values. This is my maximum value. These are the node values. Okay. Similarly, this is the maximum value, node values, and this is maximum negative value. So I hope you got this one. So if there is any further doubt, please ask me on my WhatsApp, or you can call me. Okay. Thank you. I don't want to make this video very long, so thank you very much.